So we want to know the number of skis that have above average friction coefficient. Okay, the number of means we're going to use count. And we're doing it conditionally, so it's a count if. Okay, what's the range that we go to check the criteria? Friction. Okay. The criteria is above average. We actually have that value already on our worksheet, don't we? There's the average right there. Okay. We don't want to type 0.76 in here. We don't ever want to type numbers, letters, and stuff into our formulas. I just had to get us here, okay? So here's what we do. We're going to compare to that cell. And above average would mean greater than. You put the logical operator in the quotation marks. Just the logical operator in the quotation marks. Followed by the ampersand sign and then the cell reference. Oh yeah, that's really it. Okay. Gosh, I wish I could tell you there was just something really easy to remember this by, but there isn't. But it is what you would do more often, because more often you are going to compare to cells, not to putting values in, because if you put the values in, you don't have flexibility in your model anymore, okay? And so this is the way we would do it. This is the cryptic syntax for it, okay? And that's going to give us the number of skis that have above average friction coefficient, which happens to be 13. Yes?
Can you clarify more, what does that ampersand actually do within that?
The ampersand, best I can tell, is just simply designating to Excel that what follows it is a cell reference.
Okay.
And to be honest, you don't see this in other places. Like, we're not going to run across this in anything else we're going to do. It's very specific to this, and I do know why. But
Could you have just typed the 0.76?
well, if you did the 0.76, you'd have had to do what we did on the three that were just above it. You know, in the quotation marks, greater than 0.76. But our whole point of this is we want to not be doing that. We want to not be putting hard-coded values in. So I was working us up to this in steps because it's so cryptic, but I was working us up to this because this is, you know, what we really want to do is be referencing cells. Okay. Yes.
Could you go back to the average cost of tokens skis?
Yes.
I just wanted to see if you did that. Why wouldn't then give value 11?
Did you get name in the
No, I got value. Hashtag value exclamation.
value message? Okay, we will look at that right afterwards, and can go over. You don't have to do it right now because you might want to see the next stuff, but yeah, we'll do that right after because we're almost done. But let me do something super fast because we don't have a lot of time. So you do not even have to type these in right now if you don't want to, because you're gonna get the finished file at 5:30. I'd rather you see this. I'm gonna put in here integer function on this number right here and show you what it does. It goes down to the next lowest integer, okay? We'll talk about them as soon as they're all typed in. I'm gonna truncate this number here. It does not care anything about what the decimal places are that follow it. It simply chops them off and leaves you with the integer portion of that number. Those are both unusual. They're there because we're going to compare them to these that are more common, which are round, round up, and round down. Okay? We already saw round. Round, for one thing, requires us to tell it how many decimal places. Well, to be consistent with the other two, let's make it 0. Okay? And then I'm going to do round up, which forces it to take that number up. And then I'm going to do round down. We're going to compare all this in just 1 second. Which forces it to take it down. We're going to look at all these. Okay. They're in here now, so we've got them. Truncate, you can just look at it here. Put your hand over this, what's left, that's what it used. 1, 1, -1. Okay, got that. Integer. What integer was doing was, and here are the numbers, the 1.025, the 1.9 something, 1.960, okay. What integer integer was doing, truly on a number line, up, down, it was taking it down to the next integer. And so it took the 1 down to 1. It took the 1.958 down to 1. It took this one down to -2. That's what you see up there. Are you gonna use these a lot? Probably not. They're here to contrast with what we're gonna see next, okay? The round. The round does exactly what we think round does all the time, which is go to the closest one. That's why this went to 1, this went to 2, this went to -2. Went to the closest thing. We're used to that. But you can force rounds up and rounds down. Okay, I don't know how to say that. Round ups and round downs. That's a better way to say it. Okay, you can force that. And so when you force a round up, it takes this up to 2. Even though it was closer to that one, it takes it up to 2. Takes this one up to 2. Look at that. It took it up to -2. That's down on a number line. Okay, so let's be, clear about what's happening here. We know on a number line that direction is down, that direction is up. But in the rounds, which are the ones we'll use most often? They follow more of what you would think as an intuitive type of approach to this, which is down is towards 0 and up is away from 0. And that is, in a lot of ways, a lot more intuitive. If we had had time and I had said to you, what does this round up to? If you forced it to round up, you would have probably said -2. Because intuitively it seems like it should be -2, even though in a number line that's actually down, okay? But it's gonna be up, this is gonna be down. And that's then when you force round down, this goes, the positive numbers are gonna make sense. This goes down, this goes down, this goes down as in towards 0, okay? Okay, these are the ones you would use the most. I just wanted this for comparison to see the difference in them. Don't know that you'd use them very often, but I do need to at least give you an example of why would you even choose to force the rounding to go one direction or the other. Okay, let's say you're putting on a little conference and you have participants coming to it and you pay a speaker, that's a fixed cost, and you provide them breakfast and lunch, that's a variable cost. And you do a little break-even analysis, and in that break-even analysis, you determine that you need 25.2 people to show up in order for you to break even and not lose money. 25.2. How many people do you need to show up to not lose money? 26. Okay, you got to round that one up, because at 25, you actually still lose a little money. And so you'd have to round to 26 if this was important to then carry it forward into the rest of your calculations. Let's say you're making widgets. And to make a widget, it takes this much of A, this much of B, this much of C. And you have enough A, B, and C raw materials to make 79.8 widgets. How many widgets can you make? 79. Doesn't matter how close you got, you didn't quite get there to the 80. You've got to round down, and then you carry that forward. So round up, round down, these are very, very, very useful things that we will, will come up from here and then, just sometimes will those, not so much so, but those do. And I wanted you to know how those worked, okay? And we'll come back and do the transposing data next time, but what you want to start on right now is starting in on the practice problems so that you're pacing yourself because there's a bunch of them for practice.